we'll put some dummy variables into our regressions, or as R calls them, factors. So suppose we have, keep it really simple to begin with, a dummy variable takes a value of just 0 or 1 depending on some logical condition. Usually 0 is false and 1 is true. For instance, we can do an experiment where each subject is either in the treatment group or the control group. Nobody's in both, everybody is in either one or the other. So we define two dummy variables. One is a dummy variable treatment that takes the value 0 when that's false, and 1 if it's true. Another dummy variable, control, takes a value of 0 for false, 1 for true. So if you add these up for everybody, you get a set of ones, list of ones. So we could do either of two regressions. We could regress y equals beta naught plus beta t treatment plus some error, or y equals beta naught plus beta c control plus some error. But if I create a regression y is beta naught plus beta t treatment plus beta c control, and beta naught's left hanging, undefined. When the dummy variable is for treatment, that asks us how the treatment subjects are different from the omitted category, which happens to be the control. When the dummy variable is for control, then that asks how the control are different from the omitted category, which happens to be treatment. When the dummy variable is for, both, if you put in dummies for both treatment and control, then that would estimate relative to the omitted category. But there's nobody there. There is nobody in the omitted category if we have both dummy variables in. That doesn't work by logic, doesn't work by the math. If you tried to run that in R, it would automatically drop one of the dummy variables to keep you from just being a dummy. It always helps to do the math for the dummy variables. I'm not calling you a dummy. Sometimes I call myself a dummy for not doing the math. A regression of y equals beta naught plus beta t treatment can be rewritten as two rows. Either y is beta naught plus the error, if the person is in the control group, or y is beta naught plus beta t plus the error, if the person is in the treatment group. The regression would estimate beta naught as the mean of the y variables among the control group, and estimate beta naught plus beta t as the mean of the y variables among the treatment group. Alternately, with the dummy for if the person's in control, we would write that in two rows, y equal beta naught plus beta c for error, plus error for the control group, or y equals beta naught plus the error for the treatment group. Either way, the dummy coefficient estimates the difference in means between the groups. The sign changes, of course, depending on which group is the omitted group and which group is represented by the dummy. But even that is the same size, it's just an absolute value. Now, if you put dummies for both control and treatment into a single regression, then the mean of the control group would be estimated as beta naught plus beta c. The mean of the treatment group would be estimated by beta naught plus beta t. And I'd have two equations in three unknowns. Either you have to drop one of the dummy variables, or you estimate the regression without the beta naught, with no intercept term. But usually you would leave out one of the dummy variables, because that generalizes for dummy variables with multiple categories. If I had dummy variables for which of the 50 states a person lived in, I would put in 49 of them and omit one of the values, because not to be a dummy. Now, R calls these factors instead of dummy variables. It will give you a bunch of shortcuts, and I'm kind of ambivalent about how much you want to be using the shortcuts at the beginning, because sometimes you can slide by without really understanding what's going on, and that'll cause difficulties later when you want to diagnose where the problems are coming from. Eventually you want to get to the stage where the shortcuts are valuable because you understand everything that you're skipping right over. But I'd suggest doing it the long way at the beginning. For instance, instead of having a set of dummy variables on education, I could create a single index value to be a factor. It's a bit simpler notation. R interprets that as split that factor into lots of dummy variables and do a regression with all but one of those dummy variables. I mean, you just got to make sure that R is indeed treating that as a factor. It's not like some number like age. Don't be a dummy about it.